Welcome to part 2 of our derivative rules. Here we will focus on the power rule. This rule is so important. You might even say that it's powerful. All right, the power rule mathematically is that the derivative of a power, so to take the derivative with respect to x, d dx, of x to the n is a number, so long as n is not -1. I'll add that here in just a second. I forgot that. So x to any number, what we have to do to take the derivative is we bring that number n out front, we rewrite the base x, and then we subtract 1, n minus 1. Now I do have to put on here one disclaimer, so long that n is not equal to -1. That's the only time that does not work. But it does work with any other number, fractions, negatives, positives, whatever. Now, I am not going to write this in a less mathy way until I sort of figure out how to do that. And the way we'll do that is by doing two examples first down here. Let's take a look at f of x equals x to the 5th. We want to find f prime of x using the power rule. So we use the power rule because this is a power, x to the 5th. We bring the 5 out front, that's the n value, and it's not -1. We write x, and then what goes in the exponent is 1 less than that, 1 less than 5. So the derivative is 5x to the 4th. Wow, that is so much easier than doing the limit as h approaches 0 of f of x plus h, Much simpler than that. All right, let's take a look at y equals 2x cubed. We can write this again in two different ways. I'm going to choose dy dx, the derivative of y with respect to x. We could also have written it as y prime. And there's a 2 out front, but that's okay. We are still just going to do this in the same way. So we're going to bring that 3 out front. I'm going to put a multiplication there so it doesn't look like 32. And then the x is going to be raised now to 1 less than that 3, which is 2. So our final answer we need to multiply is 6x squared. Your book puts this as two different rules. It calls the power rule basically this first one where you only have a coefficient of 1, and it calls this one the constant multiple rule. I'm combining this as one because I don't feel like it's too difficult to just multiply by the number out in front. It's essentially the same exact thing, the power rule. Let's do some practice, and then maybe we can figure out how to write this in a less mathematical way. Here are 6 quick derivatives that we will find. For number 1, for all of these, we're going to be using the power rule because they're all powers. So we could write this as y prime or dy dx, bring the 62 out front, x, and then it's 1 less. It is that simple. For number 2, we have f of x equals -5x to the 3rd. So f prime of x, I'm going to do this in one fell swoop here. We're going to bring that 3 out front, but when we do that, we multiply by that -5. So out front, our coefficient will be -15. X to the 1 less than 3. Boom. It is that simple. For number 3, we have y equals 1x, and this is x to the 1st, if that helps you out. And I'll write this one as dy dx. Again, no difference in writing y prime or dy dx. They're the same so long as x is the variable you're using. And we bring that 1 out front, so I don't need to I'll write it. And then 1 less than 1. Now, what is anything to the 0? Anything to the 0 power is 1. So this is 1 times 1. So dy dx here is just 1. So the derivative of x is 1. Sometimes the simplest concepts in math are the most difficult for students because they're so simple that they end up being challenging. And so a lot of times students will put that the derivative of x is 0, but x is not a constant. X is x to the 1st. And so long as your exponent's not -1, you use the power rule. And so that's why the derivative here is 1. Okay, let's take a look at number 4. It's essentially the same idea. So in number 4, to find the derivative y prime, again, this is x to the 1st. We bring the 1 out front and multiply it by the 2, and then it's 1 less than 1, x to the 0. Not going to write x to the 0 because it's just equal to 1. So y prime there is just 2. Now we can think about why this is very quickly. This is the line y equals 1x. Derivative is just slope. What's the slope of the line? It's 1. What's the slope of this line here? Y equals 2x. the slope is 2. Now, ones like numbers 1 and 2, they're more complicated. They're not just linear functions, and so their slopes at any point, their derivatives, are much more complicated. But these lines in numbers 3 and 4 have constant slopes. Okay, let's look at number 5. What I'm going to actually do is rewrite number 5 so that it has a coefficient that's more easily seen. This is really 1/4 x to the 4th. Okay, now we can find y prime, or dy dx. Same thing. We'll use the power rule. We bring the 4 out front. So we're going to do 4 times 1/4, and I'll write this out. 4 times 1/4. And then we raise our exponent to 1 less, which is 3. 4 times 1/4 is just 1. So this is just x cubed. And finally, in number 6, we have a fractional exponent, which is totally fine. We still use the power rule so long as the exponent's not -1, and it's not. So I'll take a little bit more room here just to show what we're doing. So f prime of x, we use the power rule, bring the 2/3 out in front. There's a 6 there, so we'll end up multiplying by the 6. I'm going to write the 6 as 6/1 just to show that we don't multiply the top and bottom by 6. Then, this is difficult for some students, so you do have to be fractionally proficient. 2/3 minus 1. 2/3 minus 3/3 is -1/3. 2/3 minus 1 whole is -1/3. When we do this multiplication to make this look nicer, what we can do here is cross cancel. So divide those both by 3. This ends up just being 4. 2 times 2 over 1. X to the -1/3. Now, in mathematics, we don't like to write exponents as negatives in our final answer. What negative exponents mean is that they belong in the opposite part of the fraction from where they already are. Right now, this x to the -1/3 is in the numerator. Therefore, this should be x to the +1/3 in the denominator. And we'll do some more practice with negative exponents here in just a minute. Let's go back to write out the less mathy way for our power rule. To write this power rule in a less mathematical way, we can say move exponent out front, and then the new exponent is 1 less. And then so long as the exponent was not -1. There we go. So that's kind of a less mathematical way to write out what we do in the power rule. If you don't need to write out the less mathematical way, that's totally fine. I just think sometimes certain students' brains look at this and it looks scary. I really don't want it to look scary, and that's why I use the less mathematical way, is to show you that it doesn't have to be as hard as it looks, really. Let's talk a little bit about negative exponents. When we see something like f of x equals 4/x², we can rewrite this as 4x to the -2. I want to rewrite it that way so it looks like x to the n. This does not look like x to the n. X to the n is in the denominator here, and we have this 4 up top. This is still f of x. I have not done any calculus yet. I've only rewritten this algebraically. Now, since this looks like x to the n, we can apply the power rule. Again, we can apply the power rule with anything that looks like x to the n, so long as that n is not -1, and here it's not. So the power rule can still apply when we're finding f prime of x. What we're going to do is we're going to move this -2 out front. So we're going to have -2 times that 4 that's out front, so it's -8. Then we want to take 1 less. Now, be careful. This is a time when students make errors and they'll write -1. That is not 1 less than -2. If you take -2 and take 1 less than that, or subtract 1, you're down to -3. And so we really haven't done anything mathematically different here. I'm just showing you what it's like to work with negative exponents on the power rule. Now, to write this in a more mathematically pleasing way, to write f prime in a final answer way, we do not want to write any final answers with negative exponents. And so we're going to put the -8 in the numerator, and then that x to the -3rd is really an x to the 3rd in the denominator. And so that's how we want to write our final answer. For this next example, we have y equals negative 1 over 2x cubed. I'm going to rewrite this as negative 1/2, that's our coefficient, and this is really x to the negative third. Now we can use the power rule because it looks like x to the n. So to find our derivative, y prime, or dy dx, we follow our product rule, and we bring that negative 3 out front, and we multiply the negative 3 times the negative 1/2. A negative times a negative is a positive, and so we'll have positive 3/2, and then we want to raise our exponent to 1 less than negative 3, which is negative 4. Again, be careful, it's not negative 2. We're going down, 1 less. To write this in a, again, more mathematically pleasing way with positive exponents as our final answer, we'll have 3 over 2x to the 4th. The 2 is also in the denominator, and so it's down there with the x to the positive 4. So that's how you can deal with negative exponents using the power rule. Next, we want to talk about fractional exponents, and you can see that my f of x doesn't look like a fractional exponent, but something we talked about in the start of the year was how radicals, or roots, and fractional exponents are related. With the square root of x, which we'll see quite frequently in calculus, the index is 2 because we're taking a square root. Now in math, we don't normally write the 2 there, but I'll put it there. And this is raised to the first power because anything is if we don't see a power. We can rewrite this as a fractional exponent, so we can use the power rule. And it is written as x to the 1/2. The index, or type of root that we're taking, goes in the denominator. So if this was a cube root of x, it'd be x to the 1/3, a fourth root, x to the 1/4, and so on. So this is a function that we can use the power rule on. It's x to an n, so long as n is not negative 1. So we have not done any calculus yet, only algebraic rearranging. Now we are going to do calculus, which I will denote with the f prime. To take the derivative, we use the power rule, meaning we bring the exponent out front. Then we take our exponent to 1 less than what it was. 1/2 minus 1 is negative 1/2. And as we just saw, we know how to deal with negative exponents, meaning it goes in the denominator and becomes a positive exponent. And since our original function was written with a root, we know that x to the 1/2 is the square root of x. So this is how we'll write our final answer, with the square root of x down below. Let's take a look at y equals 8x to the 3/4. To find y prime, or dy dx, we're going to bring the 3/4 out front and multiply by 8, which you can write as 8 over 1. Then we take x to 3/4 minus 1, and if you struggle with fractions, I recommend that you write it out. 3/4 minus 1 whole is 4/4. To do addition or subtraction with fractions, you need a common denominator. So this is negative 1 over 4. All right, so our exponent is negative 1/4. Then we multiply, which you can multiply straight across and get 24 over 4, which is 6. Or you can cross cancel first and divide both of these by 4 and do 3 times 2 over 1 times 1, which is also 6. Either way is fine. So we have 6x to the negative 1/4. Again, we do not want to write final answers with negative exponents, so the 6 is in the numerator, and the x to the 1/4 goes down below. Now, unlike in our first example, we don't change that to a fourth root of x because our initial function was not given with roots. So however your initial function was written, that's how you want to write your derivative. And so our initial function was written with a fractional exponent. That's how we can write our derivative. And in this example is written with a root, so our derivative we write with a root as well. Let's take a look at this last example here. We want to rewrite this so it looks like x to the n, and so therefore I'm not doing any calculus yet. I haven't written f prime. This is negative 1, and we know that the square root of x is x to the 1/2, and since this is in the denominator, this is x to the negative 1/2. We have not changed the meaning. These are both the same things, but this now looks like x to the n, so we can apply the power rule. So applying the power rule means we're doing calculus, we're taking a derivative. So f prime of x is, using the power rule, negative 1/2 out front multiplied by that negative 1 is positive 1/2. Then x, then we have to raise this to negative 1/2 minus 1. So negative 1/2 minus 1 whole, we're going more negative to negative 1.5 or negative 3/2. Then we want to write our final answer with no negative exponents. So it should be 1/2, the 2's in the denominator, and this is x to the positive 3/2 in the denominator. Now our initial function was written with a root, so we want to write our final answer with a root. The denominator is the type of root that we're taking, so it's a 2 in the fractional exponents denominator, so it's a square root, which we would write here, but we don't need to write a 2 because we know that it's a square root. And then this is x, and then it's cubed because it's raised to the 3/2 and not the 1/2. So there we go. We have used the power rule with simpler exponents as well as negative exponents, fractional exponents, and negative fractional exponents as well.